Welcome everyone to the Southwest Climate Podcast, the 2020 monsoon edition. Mike Crimmins, how you doing?
Hey Zach, don't call it the monsoon edition. Come on.
Yeah, so that's funny. Today I was walking in, looking up at a relatively clear blue sky, and I had this thought. I was like, wow, I really wish today's intro would be like, welcome to the July edition of the Southwest Monsoon Podcast or Southwest Climate Podcast. Mike, we just had 2 really good months of rain. They weren't record setting, but they were pretty darn good for June. I mean, think about it. If this was July and we just had those 2 months, it'd be pretty good for May and June. It wouldn't be record setting. And
right.
That's what I think is crazy. So for Tucson in August, the little bit more than 1 inch, the 1.16 inches of rain would have only been the 5th wettest June on record.
That was such a good line of stats that you and Ben dove into on that. I thought it was like, but you're totally right. You're totally right.
And the 0.5 inches for Tucson in July would have been only the 15th wettest June on record. So it's just crazy making how this monsoon has really turned out. So that sort of fantasy looking up at the blue sky actually turned into a nightmare, because now we're in like September and we have to actually unpack again what has continued the historically crazy making monsoon trend that we talked about last time. So with that, people know what they're going to get, but I think they're going to be really interested because, this has been a noteworthy monsoon in all the wrong ways. So let's dig in. But before we do with the specifics, I'm curious. I gave you a homework assignment to think about this monsoon so far and to sum it up in one word. Can you do it?
The immediate, it's like that word association game. And you set me up. The only thing, the word crispy, like that's not a normal word that gets associated with the monsoon. Everything outside looks crispy. Like
crispy, like it's sort of fried, like hot and desiccated, crispy?
Exactly. Yeah, that kind of crispy. Not like good fried chicken crispy, but more of like, oh, it looks like it hasn't rained and it's been record hot outside.
I like it. Yeah,
it's sad though. That's not the right word.
No, but I like it because it is it is a word that you wouldn't associate with the monsoon. And I think that's fitting for this monsoon because there's been a lot of things that are sort of out of the ordinary. And we were just talking prior to turning the record on that every single year, the monsoon, one way or another, delivers some new insight that makes us say, oh, I guess we didn't really understand the monsoon all that well previously.
Yeah, I guess I'll begrudgingly say that this monsoon was really instructive and humbling yet again. And like you said, I learned something a little bit different and new every monsoon season we try to kind of weather and understand. And this one was outside of my experience, living here for 20 years.
All right. So we'll make sure that we explain that. But before we do, I want to give my word because I thought about this a lot. Yeah. Here's my word: grief.
Grief.
Yeah. Because I was thinking about what the 5 stages of grief are, right? So you got denial, anger, bargaining, depression, and acceptance. And I think we've run the full spectrum there in this monsoon.
Yep.
And I was so sure of that I went back to our Slack channel and I picked out quotes that summarize each of those stages. Ready?
That's awesome.
Yeah. So get this. So here's denial. This is me and Mike on Slack, August 27th, which was one of the days that we actually got rain. And I was like, 0.35 at my house, biggest event of the season here. You respond sarcastically, no way. You got 0.35 inches out of that? This monsoon stinks. All right, so here's anger. Mike on August 20th. I'm going to lose my crap if this smoke kills the storm chances today like it did last month.
And it did.
And we should talk about that. That was in response to the fire smoke from California and Colorado just sort of sloshing about the west and really taking the top off the temperatures.
Yeah, and it was actually local smoke too. We had way more fires in Arizona in August than we should.
All right, here's my favorite. bargaining. Mike, quote unquote, this is going to be the last straw for me before I run down the middle of I-10 naked screaming profanities.
You say that as though that didn't happen. So
yeah, I still laughing at that one. Okay. Depression. Mike on August 15th. Worst summer ever. This is in reference to a week 3-4 temperature forecast by the CPC that painted the entire country under above average conditions. It was so depressing.
It was.
All right. And then I pulled one from Mike Luthold for acceptance. and Mike, for those of you who don't know, does the blog on the WRF forecast models.
Arizona WRF. Yep. Arizona WRF blog. Yep.
Yeah. One of the go-tos that we look for. So he says, August 24th, quote unquote, monsoon, put me out of my misery and bring back the westerlies. There's grief summarized.
Zach, that's so good. That's so good. You could put together like one of those Precious Memories albums for me for this monsoon season. I'd appreciate it.
All right. A little bit of an overview so people know what they're going to get is we'll talk, kind of put the monsoon season so far in context. Then we'll do a deep dive into August, picking out a couple of the weekends, if you will. They just happen to be weekends where there was more activity than not, but maybe less than we had hoped. Then we'll sort of transition a little bit into the hurricanes because September is the month where what monsoon rainfall we get is oftentimes assisted by what goes on in the East Pacific. In fact, that was the case for August. So we'll hit a little bit of that. Won't spend too much time on that. A little bit of hope or despair for September, Mike. It's a little foreshadowing there. And then we'll end it with a recap of our monsoon fantasy. So hope you all to stay around or to fast forward to the end of that because we'll go over who's leading the horse race, who did well in August. Hint, nobody in particular Ben. But yeah, and then we'll foreshadow a little bit of our September guesses and sort of put a bow on the monsoon fantasy, at least in terms of our guesses. So that's what you're going to get. All right. How you feel about that, Mike?
I feel as good as I could feel at this moment. I'm in acceptance stage.
Yeah, I think you are.
I really am. I'm so over it and done. The next month podcast will have already pivoted. We won't even do the monsoon summary probably in October. We'll already be looking forward to something else.
Okay, so the season so far in context, and we're coming at you guys in the beginning of September. So July and August are in the books. Let me just summarize this in terms of some statistics, Mike. We'll start with some station data, the 5 stations that we've sort of cued in on: Tucson, Phoenix, Flagstaff, Albuquerque, and El Paso. So in terms of precipitation for these stations for both July and August, Tucson comes in at its 7th driest on record. So for those of you who are in the places that have received very little rain, you might be thinking that doesn't sound as bad as you thought it was. But again, this is just one station and other areas have fared better and worse. Phoenix gets the most optimistic picture, if you can call it that, comes in at 26th on record. Flagstaff, 2nd driest so far, right on the heels of 2019, which was the driest. So really bummer up there for those guys. Albuquerque, driest, and El Paso, 12th driest. We could zoom out or zoom in, but the kind of picture that paints, Mike, is one of very dry conditions, and it would hold no matter sort of what metric you look at, regional or even finer scale. What do you think?
Yeah, we were talking about this a little bit earlier with Ben, and you guys pointed out to me that it doesn't happen very often where all of those stations that are stretched across the region and are in different parts of the monsoon region all have cratered together. So I think that shows just the spatial extent and depth of the failure of the monsoon here.
Right. So I'm queuing in again on just like a point and trying to extrapolate to the region as a whole, like taking these 5 stations as sort of a proxy for what the region looks like. But we know that rainfall can be highly variable, right? So ranking 7th at Tucson Airport sort of belies the spatial variability. It might be drier or wetter. In fact, last weekend I was out at Avra Valley taking photos both Saturday and Sunday. It didn't rain at all at Tucson Airport, and yet half an inch fell on both of those days, I believe, in some areas. It was the sort of epicenter was out there. And so I guess the question is to what extent do you think that classifying Tucson as the 7th driest on record is actually an overestimate or an underestimate?
We've struggled with this spatial variability issue in characterizing the monsoon for as long as we've been doing this podcast. Okay, so the monsoon season, as you pointed out, has an enormous amount of spatial variability in it because of the nature of those convective thunderstorms. So just kind of contrast that to dry winters for Arizona and New Mexico have enormous amounts of spatial autocorrelation, right? The storm systems come through, typically either give broad parts of the region precip or not. So it's pretty easy for big chunks of Arizona to go big runs together without precipitation. But the monsoon season doesn't work that way because it's not these big storm systems. It's a bunch of kind of popcorny type thunderstorms. And it tends to be on the drier monsoon seasons, you have fewer of those widespread events. And we've had almost no widespread events yet this season. I say yet, but that is like wildly optimistic. I don't even know where that came from. Came out of my subconscious.
Some hope.
I don't have it. I'm
hope and despair segment.
I'm cramming that way back down into my subconscious. I'm going to take that right out again. But we've had a lot of isolated events. And so, I was looking at gridded precipitation data for the season now, Zach. If you go out to Avra Valley and you look at Avra Valley right now, it is about 100% of average to this date. So those couple of events are super localized just outside of Tucson, just by chance picked up a couple of storms, and they were heavy storms and they got to their total. And there's a place just outside of Prescott that has had the same. They had a couple of really heavy events, but got lucky. And then, there are places in New Mexico outside of those main, in between El Paso and Albuquerque who have actually had that same. But they're spatial, there's just they're dots right on the map of these gridded estimates. And everything in between is below average.
So
the spatial
along those
extent
lines,
of the depth of it is bad.
I was thinking, I was playing around with a different way to think about this. So if you look at dew point temperature in Tucson, now dew point temperature is basically describes the temperature at which the moisture in the atmosphere is fully saturated. So it either is raining or snowing or there's fog. It's that whatever moisture is there is in liquid or solid form. Okay, so the more moisture in the atmosphere, then the higher the dew point temperature. Okay, so when we think of temperature, a high dew point temperature, it's also describing the amount of moisture there. And this is actually a hard thing to think about, I think, because the higher the moisture in the atmosphere, the less you have to lower the temperature for there to be rain. So it's a little bit of not so much of an intuitive concept. So where I'm going with that is that a dew point temperature metric would be perhaps less spatially variable than a precipitation. So if the dew point temperature at the Tucson airport might be very similar to the dew point temperature out at your house on the east side. So less variability with that than with precipitation. This was where I was going. Maybe you can rebut this in a minute. But if you look at that metric and you say, okay, well, maybe this is a better way to think about a regional characterization, or maybe not a regional as like a Southwest size, but like Tucson, for example, or slightly larger than Tucson. If you think of dew point in that terms, 2020 is the second driest dew point average for July and August on record. So it shows a little bit more of a worse picture than just looking at Tucson precipitation.
what was the driest again? Was it 1994?
No.
No, it was 1979, wasn't it?
1979. 94 was the ninth driest.
This is part of my rebuttal is that, okay, well, are you done?
I'm done.
Does the defense rest on that?
That's what I've got. What do you got?
Okay. I don't know. You're going upriver.
Just to summarize, my argument is that by looking at the dew point metric, which I argue is a better way to think about a larger area than just a point metric, it paints an even worse picture than the rainfall. That's my argument. And what's your rebuttal?
Well, okay. So my question to you, I'm going to cross-examine you now, is what's your end goal? Do you care about the precip or do you care about the characterization of the monsoon?
What my end goal was a way to be able to place this monsoon in a historical context in the most accurate way possible, given the data that we have on hand. And while we care about precipitation, the metric of dew point, which is we could be using humidity if you will, is the fundamental ingredient for. So it talks about the potential of there to be rainfall. So it's a potential metric, whereas I get rainfall is an actual metric. But the problem is it's so highly spatially heterogeneous that it's not as good of a metric for describing a larger area than perhaps dew point is.
Yeah, I know. We've had this discussion a lot over the years, and dew point's just one ingredient, right? And so, your example of ranking this year is that it falls behind 1979, which by all accounts was an enormously better precip year for Tucson, at least at the airport.
That's my point. It probably wasn't in in the surrounding area. It's just like the Avra Valley example.
This is where I think Ben's analysis with the station network will be helpful. Okay, so dew point is good. It's inadequate in some respects because it can lead to situations where it doesn't rain because other ingredients aren't there. And I think it can kind of belie the situation by not being completely explanatory on it.
Totally agree with that.
We were talking about this is that the way that I've started thinking about the monsoon, because it simplifies it for me, is that in the Southwest, the shift in the upper level circulation, what we term the monsoonal circulation shift with the ridge is really about an air mass transition. And so it goes from a dry, continental air mass in the May and June to a tropical air mass as that air mass boundary moves north. And so the dew point is that surface reflection of that, which is, it's good. I mean, and I think that it's helpful to sort of signify that.
And in the dew point, if I may just interject, as the dew point goes up, bobs up and down, you can also think about it spatially as this air mass is bobbing north and south. Yeah.
So there can be situations, though, that I'm nitpicking right now, because I think I largely agree with you. I think that there are other metrics like we know precipitable water, which is going to be the integration from the surface up in the atmosphere, is probably even better because you can have situations where surface dew points are very shallow and it's just at the surface. And when you have really wet monsoon seasons, which was not this year, you can have a lot of recycling of that moisture into shallow boundary layers. And so the dew points will be elevated where there's actually really dry air above it. And that would kill your storm chances as well. So
would that mix out during a day? So if you average the value?
Well, but again, sometimes we have shallow, mixing layers and it doesn't actually it doesn't do that, right? So it could be artificially high at the surface and then low up in there. And that would affect CAPE and those kinds of things. So yeah, I thought I felt more strongly about this until I started talking about it. And I don't know, I know what you're saying. on the sense of like, I think if you went back and you looked at a bunch of data for a lot of years, then you could say where that monsoon air mass was and that boundary was, and that would be fine. But I care about the precip. Yes. So there's that contingency of, well, the air mass was here, but it didn't actually rain, or it didn't, it's the opposite would be like the too wet to rain situation, or where you ended up having plenty of moisture and it actually rained in the mountains, but didn't rain in the valleys.
So I think we had a couple of those examples, which we'll talk about later. Around July or August 20th, the moisture surge from Harlan, Tropical Storm Harlan. And no, that was Genevieve on the 20th. And then like the 29th was Harlan. We'll talk about this. So I don't want to get there. I just want to make sure that they are actual examples of what you're saying, that we actually had the moisture around, but it didn't rain as much as we thought otherwise could with that moisture around. Are those examples this year of what you're talking about?
Yeah, and they were weird examples too, because they weren't the typical examples where the humidity came in and then it just like popped a bunch of clouds and it shaded us out. Like that's what, like the too wet to rain. We didn't have that. Go ahead.
No, I'm giving the timeout signal only because we'll get there.
Oh, okay, got it.
In a little bit, because I think that these are really illustrative examples that help us sort of get at that, what we were saying initially when we introduced this. All new learning, it partly comes from those examples.
Yes, I agree.
Well, so I agree that any one metric is inadequate. But in terms of, and I don't know the answer to this, but I think I do, but what would you say is the spatial autocorrelation of a moisture metric like dew point?
Dew point actually varies with elevation. So it has an elevational gradient. And the way that the moisture is imported and where it is in the depth of the boundary layer actually has a lot of implications for it. So like you can have a shallow Gulf surge that it's pretty close to the surface and there's dry air above it. And then you can have really deep ones where you don't have as much worry that that dry air is actually going to mess with the surface dew points. And then you also have the recycling aspect of the moisture as well that will come into play as far as surface dew points and those kinds of things. So yeah, I think it can have really sharp gradients north to south and east to west, but I think within those air masses, it's fairly continuous.
Okay. So along these ideas of like metrics, that's what I was thinking about today to try to put this in perspective. And I got just a couple other ones, the sort of gross state level ways of like thinking about July and August. And this is from the West-Wide Drought Tracker. And so these are state averages for, again, July and August and ranks. So average temperature. This is another thing that has just been off the charts. Number one, it's the hottest in Arizona on record and the hottest on record in New Mexico. And I think I saw a tweet from the National Weather Service in Tucson. Might correct me if I'm wrong, but August actually was the hottest on record. The monthly average temperature for Tucson was 92 degrees, is 6.7 degrees above normal. And it shattered its hottest August, the previous hottest August on record by 1.8 degrees. That's just Tucson. Okay, so hot all around the West at aggregate levels. Precipitation averaged over Arizona, driest on record for Arizona, and the 10th driest on record for New Mexico. And then when you combine those in a metric called the SPEI, Standard Precipitation Evaporation Index, Arizona's number one, which is driest and hottest, if you want to think of it like that. And New Mexico is the second highest. So there you have it. And Mike, it's not just an Arizona thing. Mexico, actually the core of the monsoon, has been below average too. And this is obviously a telltale sign for us. When Mexico is drier than average, there's little chance that Arizona or New Mexico will fare well. So this also got me thinking. There's a narrative out there that Arizona and New Mexico have seen a dry monsoon because the position of the ridge has been a little bit it hasn't been in a favorable position. In other words, it's been south of us, and therefore we've been under more westerly flow than easterly flow that allows for not only encroachment of moisture from the south, but we're on sort of like we're under sort of, we can get those easterly waves that can help facilitate the dynamics that produce rain. So the narrative is that we've been just in an unfavorable position, but the core of the Mexican monsoon, the Sierra Madre Occidental, would still be on the southern lim of that. And so that doesn't explain why Mexico has been so dry in the monsoon region. So how am I thinking about that right? So what would explain, what would help us understand why Mexico has been so dry?
I don't think I have this nailed yet either. And I've been kind of scouring the internet and reading a lot of discussion pages and then looking at a bunch of data. And I showed you and Ben, one of my takes on this is that overall, the monsoon ridge has not been in a great position much of this summer, right? So we've really suffered with the monsoon subtropical high, the mid-level ridge. We think of it as kind of four corners or slightly east of that, has been just pushed all over the place, right? And so there's been an active jet stream across the Pacific and across the higher latitude of the U.S. And that active weather pattern has really buffeted the ridge, and it has pushed it far south. And when it's pushed far south, we are in those westerlies like you talked about, and that whole tropical air mass that we need that's part of the monsoon retreats into Mexico. So it has also been the situation where that subtropical ridge has been pushed deep into Mexico, and so it would even shut down northern Mexico. And we've seen periods of that. We've also seen periods where the ridge has actually moved up into the southwest, and so the ridge was overhead, and Mexico was on the southern side of the ridge position, and they ended up having a week or two of really good blockbuster rain events there. And you could see that the moisture was pooled right at the border, and there was just great storm activity to the south, and we were parked under the high. And so being under the high is going to lead to those high temperatures, right? And it's going to limit our storm development. The other thing that I've noticed on the weather maps for this summer, and especially in August, is that there's been a pretty frequent trough that's moved through the eastern U.S. And so you can think of that kind of cold air spilling on top of the ridge that's over the west. That's our ridge that we're underneath. And that cool, dry air, it's coming out of the Dakotas and it's spilling south into kind of the Mississippi River Valley. But what ends up happening is that...
Can I interrupt?
Yeah, go ahead. Yep.
So if you were to draw on the map, the position of the jet stream that would help delineate the sort of trough, so for people that are listening, what would that look like? Would that jet stream be going across the Pacific Northwest, and then it sort of goes a little bit south, and as it crosses the Rockies, it sort of plunges south and sort of its bottom position bottoms out in northern Texas? I'm doing this from
no, that's
memory.
Good. You're thinking of the geography right. It's probably not that pronounced or deep because it's summertime, right? We don't have ridges and we don't have dynamic ridges and troughs of that magnitude. But there's been one that's been subtle enough that has been, so think of, the ridge is over the west. And like you said, the storms are riding up on the top of the ridge. So through the Pacific Northwest, kind of up even into Canada. And then you're now starting to dip down through the Dakotas and the upper Midwest, right? And that could be a low pressure system. And a high pressure system follows that at the surface. And that's cool, dry air that spills south. Well, that cool, dry air that spills south can eventually make its way all the way down into Texas, and then can get caught up in the mean flow around the ridge and then imported back to the east. And so
it's actually entrained east because
west. Yeah, it's entrained west. Yeah, I'm sorry, I got that wrong. Yeah, so it's entrained west. So it's cool, dry air out of Canada making itself all the way around the surface at surface levels and getting mixed up in the atmosphere and then moved to the west, and that reduces precipitable water. And then you can get a dry easterly flow. And it's been fairly deep too. It's been through Texas and through northern Mexico that you've seen this dry air move out of the east, right? And so that's as much as I can see in these weather maps. You just see that over and over again. You don't see this deep easterly moist flow out of the Gulf moving across northern Mexico. That's a little more normal, is that you've got low-level moisture coming out of the Gulf of California surge events, up the coastal plain of Mexico, coming out of the storm events in Chihuahua and northern Sonora. So that moistens up the low levels. And then you've also got easterly flow coming out of the Gulf of Mexico that's moistening up and delivering precipitation to New Mexico. And then at the mid to upper levels is actually intersecting with our air mass. And so you end up having this deep air mass that's moist, right? That's like the gangbuster great monsoon season. But instead we've had this really dynamic jet, dry air getting imported in, and I think drying out and killing a lot of convection, even across northern Mexico.
That's crazy. You can have like Canadian dry air that is able to sort of recurve, like it goes east and then it goes back west all the way in Mexico and sort of stifles some of the rain down there. And so have you seen that before?
No, I haven't seen a monsoon like this before. So I don't know. I never paid attention to it much. I think that during the summer, if you look at the climatology, there's, the ridge is definitely can be expansive and cover a lot of the United States. And there's usually a little dip through the upper Great Lakes, right? Because it's a little cooler and there's a little bit of a response to that ridge position. But typically, the U.S. can kind of bake under these giant heat dome ridges, and the humidity can be enormously high across the Midwest. But we haven't seen that. You see like cooler than average conditions in some parts of the Mississippi Valley in August, and you see some places were wet because they were getting cold fronts associated with this flow pattern. And I think it actually looks like, some of the dipole patterns you'll see with dry monsoons and even wet Great Plains, but you look at the maps, it doesn't look like that because it's not real wet in the Great Plains. It's actually been quite dry. And so it's not, I don't know. I don't get it. I can't quite sort it out. I think that pattern is there. This wavy jet, it's got some upstream forcing. I'm not sure what it is. If it's sea surface temperature anomalies or it's something tropical, it could be the East Asian monsoon.
This is what I love about weather and climatology. There's always something upstream. It's like, oh, so what then caused that jet stream to have that kind of a position? And of course, this is like, I don't know if you've been getting this, but I've been getting this question quite a bit, particularly in these extreme years. People want to sort of put it in this context and understand, is this the future, right? So here's my take on this. This is my standard answer, not standard. I'm actually developing it because this monsoon has given me new things to think about, but I'm curious to know what you think. So in the context of a warming world, I was thinking that a monsoon might come. Well, first of all, I should say that it's really hard to detect a signal from the noise. And so we don't really have a good understanding of this in the observational record because the monsoon is so variable, and that when you have high variability, it takes a really big change for you to see that change outside of that variability. And we just haven't seen a very big change. So we can't really look at the historical record and see any overt patterns. So we have to sort of think about theory and think about our tools, the science tools, these climate models, which are imperfect tools to try to think about what might happen. So in theory, given that the position of the high is so important, that as it moves north with the warming of the continental landmass and increasing the temperature gradient between the continental landmass and the Pacific Ocean, that's an important driver of the monsoon, that temperature differential. And in a warming world, one might expect that an earlier march north, so an earlier onset of the monsoon because of the increased temperature gradient, and then perhaps a more further northern position, mean position of the monsoon ridge, which would give us into more favorable monsoon conditions. But of course, this year, so my answer would be, I would think that a warming world would actually increase the chances of a more robust monsoon here in the Southwest. I should caveat this by saying there's certainly no definitive answer, and it's not my expertise, so I'm just paraphrasing what I've read. But what's your take on that, Mike? And do you think that this is a season is at any way analogous to what we might see going forward?
Boy, you've got that question a lot, and my first reaction is that I don't think this is a good analog for future climate change, right? We do need to kind of like tease apart the temperature aspect of this summer too, because the failure of the monsoon right now looks like natural variability, and the temperature aspect of it, the reason it was so hot is largely because the monsoon has failed. But I don't think you can get to the level of temperatures that we saw during a failed monsoon without climate change, because we've had past failed monsoons, maybe not to this extent. So the temperature aspect of it becomes a little trickier, but I think it's impossible to say that climate change isn't part of the temperature aspect of this. Now, is climate change part of the monsoon failure? I don't know. I mean, this is an attribution question. It doesn't seem like first order, the circulation pattern, and we've been talking about that ridge position, looks like anything you see in the climate models going forward. So the CMIP5 models, the latest generation previous generation of climate models, looking at July and August subtropical ridges across the continental US, they increase in height. They don't increase, they get slightly bigger, but they don't fundamentally reorganize in position. They don't seem to move north or seem to move south. They get bigger. And there isn't this wavy jet pattern that comes out in the mean model as well, which I think is part of the reason this monsoon has been really problematic, is that the active jet pattern during the summer has been moving the ridge around, and has also been introducing that dry air that's been getting entrained back into the region. So that doesn't mean that there aren't like second and third order changes afoot right now. What's causing the wavy jet? Is this the wavy jet thing that we've been kind of arguing about in climate science?
No, which is a name, the wavy jet thing.
The wavy jet thing, right? And I think it is the wavy jet, the WJT. It's like the MJO, but it's the wavy jet thing. So is it something upstream? Is it upstream forcing that's not natural variability? And also, there's upstream, since we're related to the tropics, is also in the Atlantic sector right now too, right? So the variability that's going in the Atlantic, since we're talking about the movement of the ridge, is the easterlies actually upstream is to the east of us now too. So is there some component of change there or not? I mean, if we're really interested in solving that question, we would need to do a climate attribution study where you would run models, pre-industrial greenhouse gas concentrations with observed, and try to see if there's difference between them. And I'm positive the temperature aspect of this season will come out, but I'm not so sure the precip aspect will come out.
It's also worth saying that regionally, or synoptically, as they say, there's a set of important things to consider. But then even if those are producing, let's say, favorable scenarios, there's also that really like fine-grained, what's Cape doing or what's the winds doing? And it's like, really, to get at a future monsoon, we kind of have to have the tools to be able to put all these things together. I'm not sure we're there with those tools, but I do think from first principles, it is worth thinking about the synoptic patterns and just thinking about it. So I guess one question I have is, if the high is expanding, maybe not perhaps changing its average position, and of course, during the year, that position is going to be moving around. So the averages sort of an abstraction. But if it's just expanding, that would sort of push the circulation further away from southern Arizona, right? Would that itself be more favorable? It would be less favorable, wouldn't it? Or would it also be a situation where it would probably lead to greater variability?
So there's a paper by Lammers, I think it's 2016, and that was one of the ideas that came out of that analysis was historical analysis of looking at the idea that the subtropical ridge, the monsoon ridge, is actually expanding, and that then having a larger field of those geopotential heights pushes easterly waves south, right? And so the triggering events that would cause the thunderstorms that would lead to kind of local forcing of precipitation or outflows or even Gulf surge events would get shoved south. So your previous point with synoptics is that a good ridge position can solve a lot of problems during the monsoon. A lot can go wrong, but a lot can go right when the ridge is in the right spot and you had everything else set up kind of antecedent conditions well. And we can usually skate along and at least get smaller scale regional events that will bump us along in a monsoon season. But if the position is overhead and it's even shunted moisture further south, there's just no real good way to dig yourself out of that. And, there's a couple of papers out that looked at monsoon projections, and, there's going to be a tussle between, in a warming world, having a less favorable thermodynamic profile with increasing water vapor at the low levels of the atmosphere, right? And so more water vapor at the low levels can overcome a lot of those thermodynamic problems, related to CAPE, but also warming can have the opposite effect, up through the profile as well. So this is why I think, to your point, is that then you get into those like little nuances and moving parts, and the local scale nuances become really important. And the climate models just can't do that. I think what they can do well is try to get a sense of where that ridge position is going to be in the future. And then we just kind of have to see how everything else shakes out underneath it.
Interesting. Okay. I'm looking at the time. We should move on. All right, Mike. So August was bad. Let's not sugarcoat it, but we had a couple periods where there was hope. And I actually got excited. One of them was I think around August 20th. And that was the product of what ultimately became a major hurricane. I think the first major hurricane in the East Pacific, Genevieve. And then we also had one at the end of the month, around August 29th, just actually, I think it became a tropical storm, rapidly waned, but became named, and its name was Harlan. Okay, so interestingly, when you look at the dew point data in Tucson, there's just a few times, this is so depressing, there's just a few times where it's above average all year. From July 1 through today, there's only 4 times the dew point was above average. Once around the beginning of July 1st, there was a period around July 21st, and then Genevieve and Harlan. Okay, so in fact, Harlan produced the highest dew point temperatures, so the most moisture at the airport in the air all year. And yet, we didn't get that much rain. So what gives?
A quick editor's note. Is it Harlan or Hernan? Because my notes say...
I wrote it wrong. I think I got autocorrect. Hernan,
yeah. So Genevieve, yeah. Hernan, and Ezel, too, was like right around the same time.
Yeah. I that was an autocorrect.
Good job, autocorrect.
Nice catch, though. Let's properly pronounce it with the Spanish.
Hernan, yes. So what happened? Well, you know what? I'm gonna step back because our podcast in early August, I had like this little spring in my step kind of towards the end. Do you remember that?
Actually, you called this, Mike.
Yeah, you know why? Because
the
forecasts were good. And the forecasts were good because we had a strong Madden-Julian oscillation that was in play. And, this was actually, I thought, really cool because you could see this wave pattern moving around the planet. And the forecast picked up on it, and it was like over 2.5 weeks out, I think, at that point. And the August 21st forecast of this MJO put this bullseye of, rising air at upper level, mid to upper levels, diverging air right over the East Pacific, right? And so that was the signal that the East Pacific was going to pop, and it was going to start to spawn some tropical storms. And it did. And, the forecasts for the MJO were really pretty good, because we were in one phase in early August when we talked, and it moved right around and it peaked right about that time. And like you said, Genevieve formed right as that favorable Mad-Julian oscillation phase moved right over the East Pacific. So that was great, right? And so that was what I was actually holding on to in that situation, was that was going to trigger the Gulf surge, and it did, right? We actually had an increase in precipitable water, as you noted, and we even had some slightly favorable CAPE, and the temperatures weren't too bad either. And it actually did spawn some active weather across the region. It just didn't happen at my house.
Did it not just happen at your house, or did it underperform in sort of like a more widespread way? Was there regional rain and just it missed the Tucson metro area? Because what I remember is that, and this is something that I feel like has been talked about more this monsoon season than previous ones, and that is there was a cap, and maybe we can talk a little bit about the cap. So the temperature profile was not favorable because it was warmer at slightly higher positions in the atmosphere that really prevented the air from rising. So while there was really high CAPE, convective available potential energy, so like the atmosphere was like set to go off, there was also this cap holding it back. And so a couple questions, talk a little bit about that, but also, has there been more capping this year than normal? Because I've heard people talk about that more than what I remember previously.
I wish I had a deeper well of climatology of some of these events, and I only end up responding to like what just happened to me, so I don't have really good climatic context. But and this was the blogs we were all reading, Mike's blog, and Bob Maddox, and reading the forecast discussions from the forecast offices, and all those kinds of things, is that Genevieve did cause that strong Gulf surge. That Gulf surge moved into the lower deserts. And again, this is like very Arizona centric, and I apologize, this is not really New Mexico at this point, because, we're really focusing on sort of the Gulf of California moisture source at this point. But as Mike notes in his blog, that the first day of Gulf surges is you're bringing in this cool wet air mass at the surface. And when you do that and you sort of suck it into the low deserts, the air right above it can be warmer. And so that can actually create an inversion, right? So that's sort of a surface inversion, just because you've got one air mass at the surface and a drier, warmer air mass above it, right? And if it's a shallow surge, that can be really problematic, because you'll have this real strong gradient from wet at the surface and dry above. And as the sun breaks through that inversion, it starts to mix the dry air from the bottom and the cool wet air in the surface together. And so that then changes the character of the air mass. So you can have this thing where if the air mass is really cool, you actually have to throw a lot of solar energy at it, and you may mix it out a little bit, but then the boundary layer is actually quite shallow. And then it might take a couple days that eventually you get rid of that inversion, but you've mixed in so much dry air that you've kind of ruined the character of the air mass. So that can happen. And so these Gulf surges were fairly weak. And we also have seen inversions at upper levels, which are often related to the position of the subtropical high, the mid-level ridge. And that, if it's overhead, can be the place where you're getting a lot of sinking air. And so sinking air will warm the profile and can cause an inversion in the upper levels of the profile. Again, a good ridge position can solve a lot of these problems. And if you don't have it, you're not going to win. I think we were fighting a lot of those variables. That initial Gulf surge day, though, is one of your Avra Valley rain events. That actually did trigger, and it was where the moisture was better, which was closer. As you went west, you got deeper into that air mass. And so that was just the better spot for those thunderstorms to form and propagate a bit to the west, I think, in that event.
Yeah, I feel like Sells has done fairly well.
Yeah, I don't actually know the stats off the top of my head, but Tohono O'odham has, again, they're not above average, but they've seen probably more activity than a lot of the rest of Southeast Arizona.
Well, just looking at the Genevieve cross-section, looking at Tucson's cross-section during the Genevieve event, and it's basically higher values on the west side, and it goes to virtually nil or trace on right up against the Santa Catalinas and the Rincons out where you live, Mike. So you're right. When you said it just didn't rain at your house, you're kind of right. I mean, there's, out in on the west, it's like an inch, slightly above an inch, and it goes all the way down to, just less than 1/10 of an inch out east. So, well,
the airport caught its biggest event of the entire summer on that initial Genevieve surge day, right? And it was when I think you were out chasing that night and getting some pictures. It was that night. And so we watched it off to the west. I thought was really interesting is there was a couple days there is that the next couple of days, there was this slow seep of moisture. So the surge actually persisted for a couple of days, and precipitable water went up for a couple more days, and Cape actually improved the next couple of days. On the 23rd, I think it was the 23rd, do you remember the storm event that was was the best lightning I've seen actually in years, and it was off to the east of Tucson? And so there was this line of storms that was forming up in the Mogollon Rim, and it looked like it could have been one of those rim shot days, and they formed there, and they were moving south, but they got stuck at a line that literally ended at the Tucson boundary on the eastern side of town. So I watched this amazing lightning show, and we had this outflow about 40 miles an hour come out of the storm, and it was that's what you needed to kick it above the inversion that was in the atmosphere that day. And you saw the clouds form above you, and they just faded back into the moonlight. It's just like we were so close to having one of these really good epic kind of local thunderstorms. And
zeros.
It was zeros, and it was just on the other side of the Rincons, which is our mountain range outside of Tucson. There are places that got 3 and 4 inches out of the storms.
I'm looking at rain log data, so there's a lot of zeros.
Yes,
it's not just at the airport, is my point.
Precipitable water kind of tanked again after that event, and I can't remember what actually happened, but then we were still in this favorable East Pacific tropical storm phase of the MJO, and that's where we still had a couple more storms. So Hernan and Ezel formed and caused another surge later in the month.
But Ezel we didn't see anything from Ezel though, did we?
No, I thought it was kind of like wasn't it another storm down off the tip of Baja? Maybe.
Yeah, I'm looking at its track right now. It actually it moves west to east, and it sort of fizzles out basically central Baja California peninsula. So
I think it was part of just that cluster of storms that helped sustain a surge, and we got really high precipitable waters again in Tucson, at least out of that event.
So those are the two. That's it for the most part, Hernan and Genevieve. And so begs the question, Mike, hope or despair for September?
Acceptance. I'm not despairing anymore. So you know what I got excited about in the forecast was a low of 64 on Wednesday morning. Like I'm done. I've moved on to fall. And so if we're going to do fall weather, let's bring it on. Like I'm kind of done at this point.
Okay. Well, that's changed the playing field a little bit.
It has, hasn't it?
Now it's like now your hope is like about the westerlies.
Yeah, like I'm with Mike. Is like, if we're not going to do this, let's stop screwing around. All right, like I'm just ready to move on.
But in the context of a wet September, listen, I bet that Tucson would see over the monsoon season 117% of average. Like, it is still literally possible for me to hit that target with a huge September.
What number do you need?
I don't know. I think it's something like 5.6 inches, which has happened once, I think, or something like that, or close to. One time it's been close to that. So my point is
so you're saying there's
anything, a month ago, when you looked out 2 weeks and you saw this MJO in a favorable sort of position for East Pacific activity. Do we have anything like that in the future?
No. That was part of my my forecast was leaning on the MJO signal, and it's bad. It seems to be bad to the end of the month. I'm just making sure I've got try to get the updated forecast here.
So the East Pacific.
It's bad. Oh, Zach, by the end of the month, it's like as bad as it was in the early part of August.
What are you looking at?
I'm looking at the MJO signal. So it's a suppressed tropics season that we saw earlier in August comes back. It's basically already fallen apart, right? So we were in that window and we saw those tropical storms that did indeed give us those Gulf surges, and we couldn't make much out of them. We certainly didn't get any big events, and we certainly didn't have the high in the right position to actually drag them up proper. The high ended up being in this really miserable spot where the surge had to kind of sneak in underneath it rather than it getting guided up in here. And so it ended up being pretty shallow. That's gone. And we're now back into this suppressed phase for the tropics right through the end of the month. And the CPC forecasts for the 8 to 14 and out through the rest of the month are not optimistic.
Boy,
if it rains again, I'll be surprised.
Oh,
I don't even care. Like, seriously, if it rains again in September at Tucson, I'll be surprised, which is saying something, because if we don't get any more rain, that's really, like, we're beating some of the previous monsoon season records by a fair amount.
So the driest monsoon on record, 1924 at the Tucson airport, is 1.59 inches. So if we got zero rain, we would be 0.03 inches above that. So it'd be virtually the driest on record. So
yeah, and there was no airport in 1924 or whatever. So I don't know where that reading was taken.
That's right. That was probably right in a more Avra Valley.
That's right. It's probably, your wet Avra Valley location.
Okay, so it doesn't look like the East Pacific is going to save us, and it is worth noting that that's going to come in. That is the East Pacific is likely to come in at below average hurricane or tropical storm hurricane activity. So on average, there is 15.4 named storms. We've had so far 9. There's on average 7.5 hurricanes. We've had 3, and of those 7.5 hurricanes, 3 or slightly over 3 have been major, and we've only had 2. So, of course, the hurricane season goes through October. So there's still time, but it's not looking likely that the East Pacific will reach its average. So below average, which frankly people expected, or NOAA expected. I can't remember what their forecast was, Mike. I don't know if you remember off the top of the head, but I think it was enhanced chances for below average activity in the East Pacific.
That's correct. It was like average to below average, and it was largely correct.
It's worth just saying, and let's not spend any time on this because I want to move on, but it's worth saying that this is in stark contrast to the Atlantic, which has been blazing so far this year. It's let's see. So the Atlantic hurricane season, it's the first one on record with 9 tropical storms formed before August and 13 before September. So that's pretty amazing. Let's see. It has so far had 15 named storms. On average, it only receives 12. And so we're now entering into the climatological peak of the Atlantic hurricane season. So more will be added to that. Unlikely to break its record. Its record was 28 named storms in 2005, the Hurricane Katrina year. But nonetheless, it's a very active season in the Atlantic. So we don't have to spend any time on that, but it is worth noting that the Atlantic's been very active while the East Pacific has been less active than normal.
So Ben was trying to lift my spirits and slacking us a couple of forecasts. And I'm looking at the ensemble forecast brings a tropical storm right up into Arizona on September 17th.
Whoa, that's like 2 weeks out.
Yeah, I know. These are novelty forecasts at this point.
I mean, you gave me from the lens of the monsoon, you gave me a lot of despair, but I'm going to end with that hope. Okay. So to wrap this up, Mike, let's revisit our monsoon fantasy. First, I just want to go over the 2 month total. So we actually had 15 people who have played both months. And again, I'll make a note of this. For the winner, we'll pony up some of the swag that we have available for people, shirts or a mug. So just make a plug for that if you're interested in getting our cool logo and putting it on a shirt or a mug. So of those 15 people, but Doug, riding his high score of July of 21, is still leading, even though he only scored 5 points in August. So Doug is leading at 26 points. Ned, friend of the pod, Ned, is coming in at second at 25 points. And then we've got a number of other people at 2 people at 22, 1 person at 21. And then I come in at 20. So I'm still in the running for the lead. Mike, you come in at 18 points. And Ben, out of all those 15 people that have played twice in a row, is bringing up the rear. He's the caboose at 5 points. Ben, I don't even know how you're doing this.
I'm not sure either.
It's pretty amazing. I mean, like, he is 7 points below the second to last place person. So kudos to Ben for that. I mean, he should get a prize for that.
We'll give him a prize for that.
Okay, what actually happened in Phoenix was the precipitation fell in the 50 to 60 percentile range. Tucson, 20 to 30 percentile. Flag, 0 to 10 percentile. Albuquerque, 10 to 20 percentile. And El Paso, 0 to 10 percentile.
What would possess a sane person to pick the 0 to 10 percentile?
I don't know. Persistence.
That's true. And I'm kicking myself for not being despondent and picking those percentiles for September. Like, there was still that little part of me that thought, oh yeah, one of these storms will waft up here. And
we actually had a score of 26, which is pretty remarkable.
Yeah. Yeah.
And again, Mike, so you came in at 11, I came in at 5, Ben came in at 1. So again, our totals are 20 for me, 18 for you, and 5 for Ben. Each of us can win amongst the 3 of us. But I will say this, one final thing. I ran the numbers through our random guesstimator just to see if where your 11 points would fare versus just randomly guessing. So I did 100 random guesses, 100,000 random guesses, and then I'm going to report the average value in points of those random guesses. And it turns out that the average is 9 and the median is 10. So Mike, your 11 was in the 63rd percentile, so not bad.
Yeah, better than climatology, baby.
My 5 was in the 40th percentile, and Ben's 1 was in the 13th percentile. So one may seem bad, but still better than 13%, 13% of the individuals.
That's awesome.
All right, so moving forward, we've done our guesses for September, and I'll just make a note. I won't go through all of them, but only to say that every single one of us, you, Ben, and I, picked not one of the stations to be above average. So we all of our percentiles are at most 40 to 50 percentile range. So we're all pessimistic. We're like, I remember starting this off thinking, like, most times, very few times, few seasons in the past, has there been just 3 bad months. Usually there's one good month at a particular station. And I'm going against that this time. And Tucson for you, Mike, 30 to 40. For me, 30 to 40. And Bend's even worse at 20 to 30% percentile range. There you have it. You know, you caught up, Mike. You're still there. So anything you want to say about the monsoon fantasy?
I should have went drier for this month. I always drift back towards a Climo pick.
Yeah, I kind of wish I had gone lower too. I mean, we both have 40 to 50 percentile range for Phoenix. Ben's got 30 to 40. Yeah, what you just said about the not looking good for the East Pacific does not give me much confidence that we're gonna see much of maybe one rain event at the most, or hopefully.
I'll be surprised. It's like Flagstaff should be getting regular rain, and if it gets in one more event, I'm really worried that they may not even get one more event. Tucson too. I'd be really surprised if we get one more event that actually hits the airport in the next couple of weeks.
Boy,
I think the worst outlook for your scores is that you're close to my guesses.
Well, we're psyched that people find this fun enough to play multiple times and even just once, and hopefully
it's more fun when it rains too. So
yeah, I know. It's like I think this bodes well for future seasons that are actually wet, because the monsoon has a way of, like, when it's going, it has a way of like galvanizing people. And this is like, as you said, you've just already moved on. I had to remind you guys to make your entries and to Ben to send out the email. It was like, this is an afterthought.
You've been to those games where you're packing up third quarter, right? And you're like, I'm just going to go back to the car and drink. So that's
Totally.
what it feels like. Like, this is a waste of time.
That's a
And
good way
I've got
to-
other stuff to do.
Well, the good news is a 1 month total can actually catch you up pretty well. I want to point out, you caught it, Zach. I think it's Nick up at ASU. I don't think he guessed in July, but he's technically in first place with 1 month of overall, because he's at 26 now, right?
Yeah, so
Or is he tied?
he's actually tied, and we will include if you only played once or twice and you win. Okay, well, thanks everybody for spending an hour or so with us, and happy, I don't know, I can't even get that out of my mouth. I was going to say happy the rest of your monsoon, but Mike, for your acceptance, any parting shots?
So I just got a text from my uncle in Colorado there's a forecast for snow in the Rockies on Tuesday. So I give up. This climate stuff's too hard. I'm done.
That's the sign of the Westerlies. All right.
See y'all.
Yep. Have a good rest of your month.
I think you changed up some of my words.
I did actually. I
appreciate you sanitizing them a little bit. Yeah.
I sanitize this so all of the people can fill in the blanks. That they're more PG-13.